Let's start with a big question. One that sounds like it's straight out of science fiction but is actually being worked on right now. Can we really use AI to get rid of traffic jams forever?
Seriously, just take a moment and picture it. No more soul-crushing rush hour. No more crawling along the highway. Emergency vehicles get exactly where they need to go instantly. It sounds like a dream, right? Well, that dream is getting closer to reality.
And the key to unlocking this future is a technology called V2X, which stands for Vehicle to Everything. Now think of it like a giant social network, but for cars and everything around them. We're not just talking about cars talking to each other. We're talking about cars talking to traffic lights, to your phone as a pedestrian, to the cloud. It's a constant, lightning-fast conversation to coordinate the entire system.
And this all leads to the promise of what we call smart roads. See, this is so much bigger than just having a smart car. It's about building a fully connected ecosystem, where every single piece of the transportation puzzle is talking to every other piece.
So let's break that down real quick. You've got cars warning each other about a sudden stop. That's vehicle to vehicle, or V2V. You've got a traffic light giving your car a heads up that it's about to change. That's vehicle to infrastructure. It can even be a cyclist's phone telling cars they're in a blind spot. That's V2P. And all of this info gets beamed up to the cloud for the big picture analysis.
Okay, but here's the problem, right? This amazing, constant chatter, this social network for millions of vehicles, it creates its own kind of traffic. What in the world happens when you have millions of cars trying to talk all at the same time every single second?
Well, you get a digital traffic jam. The very system that's designed to get rid of gridlock could get gridlocked by its own data. And for this to work, especially for safety features where every millisecond counts, you absolutely have to manage that data flow before it becomes a problem.
So, how do you handle that potential data overload? You guessed it, this is where AI comes into play. Researchers are essentially training AI to be the ultimate air traffic controller, but for this massive data superhighway. And look, this is not just a theory. As this research from Magdi Saudi and their team points out, deep learning models are actually amazing at this kind of thing. They can look at these ridiculously complex streams of data and get really good at predicting what's about to happen next.
So the researchers basically set up, well, I like to think of it as an audition. They brought in a bunch of different AI models and put them all through their paces to see which one could be the best AI brain for predicting this V2X network traffic. So let's meet our contestants. In one corner, you've got the recurrent neural networks, or RNNs. These guys are the memory experts. They're built to understand things in sequence, remembering that, traffic is always bad at 5 p.m. on a Friday. And in the other corner, you have the convolutional neural networks, or CNNs. These are the pattern spotters. They're fantastic at looking at a single snapshot of data and instantly identifying important features, like the telltale signs of a bottleneck forming right now. Two very different strategies for the same goal.
So how exactly did the researchers run this great model bake-off? Let's take a look at their method.
It was actually a really smart three-step process. First, they built a simulated smart city to create a whole bunch of realistic V2X network data. Then, they took most of that data, about 70% of it, and used it to train all the different AI contenders. And finally, for the big test, they showed the models the last 30% of the data, stuff they'd never seen before, to see how well they could predict what would happen.
So how do you score something like this? Well, the first metric is all about accuracy. It's measured with something called RMSE, or root mean squared error. All you really need to know is that it measures how wrong the AI's prediction was. And just like in golf, a lower score is way better.
But being accurate isn't enough. It also has to be efficient. And that's measured in something called flops, which is basically just a count of how much computer muscle the AI needs to flex to get the job done. A lower flops number is great because it means the AI is cheaper, faster, and uses less energy, which is a huge deal if you're going to put it in millions of cars.
So, we have the players, we have the rules, and we have the competition. It is time to see the results. Who actually won this bake-off? Okay, so among our memory experts, those RNN models, there was one clear champion when it came to just pure accuracy. A specific type called a GRU model. It just nailed the predictions time and time again.
And here's the number that proves it. The GRU model hit an RMSE score of just 0.4735. To give you some context, that wasn't just the best in its category, it was the lowest error score of every single model they tested in the entire study. Just a knockout performance on accuracy.
So this table really tells the whole story. The GRU model, our memory expert, was the undeniable king of accuracy. But Then you look at that efficiency column. The CNN model, our pattern spotter, was way more efficient. It needed a lot less computing power to do its job. And this sets up a classic dilemma. Do you go for the absolute best performance, or do you choose something that's more efficient and easier to run?
Okay, this is all really cool research, but let's bring it back. Why does any of this matter to you and me? What does finding a better AI traffic predictor actually mean for our lives?
It's actually pretty simple. Every single time we find a way to make these predictions a little more accurate or a little more efficient, we take one giant leap closer to making this whole smart road idea a real thing, something you and I will actually see on our daily commutes.
And think about what that reality looks like. It means smoother commutes for sure, but it also means ambulances and fire trucks get to their destinations faster. It means our streets are just fundamentally safer because cars can see accidents before they happen. It even means better 5G networks and less pollution from cars just sitting there, idling in traffic. That's the future this kind of research is building.
Which kind of leaves us with one last big question. We started by asking if AI can solve traffic, and it seems like the answer is a pretty strong, yeah, it's getting there. So now we have to ask, what's next? What other huge everyday problems should we point these incredible tools at?